Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. In the previous video, we generated a time series image or time series map of the region of interest, of nighttime light intensity in my region of interest. Remember, the time series is the average of the entire region of interest, not a particular location or locations within the region of interest. So that time series may or may not be representative of all the individual locations within the region of interest. So what we want to do is, on top of generating a time series for the region of interest as a whole, we also want to create time series for specific or individual locations within the region of interest. So we want to create not just one time series, but time series for each and every single location, whether that is 100 locations, 200 locations, 400 locations, 500 locations, whatever the case might be. We want to create a time series, in this case of nighttime light intensity, for our selected period for each and every single location. Now, regarding the locations, you can either manually select your locations, or you can just randomize the locations within, let's say, QGIS, for example. So in my case, I have my region of, by the way, this is in QGIS. I'm working in QGIS. So in my instance, I've got my region of interest. Remember, this is the same as what I'm using in the Earth engine. So I've got my region of interest. I can either now manually identify locations, let's say in the main cities or urban towns or rural settlements or wherever. So I can either manually select multiple locations, or I can simply just choose the random function within the processing toolbox, find the random points in polygons. That's my function that I'm going to use. I'm going to create random points within this polygon or within this region of interest. Double click on it. Now the first thing you'll see is in degrees. Now in my case, it is going to be irrelevant whether it's degrees, because I'm not going to use this particular function. I'm just going to say within that specific vector, I'm going to use 200 points. I'm not going to use these options, but if you're going to use these options, make sure that your measurement is not degrees but meters. I'll quickly show you how to do that. So I just basically choose my vector file, I choose how many points, and I simply run. But let's, for argument's sake, say you want to make sure that they are a specific distance from one another, so that they're not clustered around one or two specific areas within my region of interest. So I can simply go to my vector option, I go to data management, and I say reproject. What do I want? I want to reproject my input layer or my vector layer. The current coordinate reference system is EPGS4. I know if I drop down that selecting the 3857 pseudo Mercator gives me meters. So I'll just basically press run. I'm not going to give it a name or save it because I'm going to delete it. Now, I've got my read projected. Let's put points. You'll see it's now in meters. So I'm going to say 200 points. Now I can specify the distance between the meters, but as I said, I'm going to leave that open to QGIS to decide the randomness, but distance midway. So I just press run, and voila, it has generated 200 random points. So if I right click on that, I go to open attribute, you'll see that all the points are located there, and it immediately gives me my coordinates of each and every single point. Now that's very important because um, uh, in Google Earth Engine, obviously when we generate the time series for these individual points, it's going to need these coordinates and stuff. No, that's not the. We have to add the centroids or the coordinates of each of these files. Another important item that we have to look at is this unique identifier. Remember, it's called rand underscore point underscore ID. Remember this. This is very, very important. I'm just going to basically read. Yeah, no, let's leave it like that. Remember that name. That's very important. But what we need to add here is the coordinates for each of these points. And we can use either the centroid function or we can use the we can use in attributes table, we can use a calculator function. Open the field calculator where we can add the geometry x lang geometry. Returns the geometry of the current feature, or we can simply use the x dot x coordinates, the x the lats and the longs in there. So you can use that function. Ultimately, what we want to get to is, come on, is if I open this, this is already one that I've made. You'll see there's the X and the Y coordinate and the rand. In this case, I have changed so that it's not underscore ID, but just rand. So the three important points of the random points is that I have a unique identifier for each and every single location, and each location have an X coordinate and a Y coordinate. So that's very important. Now that I've generated my points, random points, remember again, you can use any random points. I will then upload that points into my script. Remember again, I go to my Earth Engine, I go in the scripts column, and I find the script or the project that I was working, and I open it, and I said, as a matter of course, I run it and save it. Now, what I need to do now is I need to upload that shape file or that vector file that is my points file into my script. Remember, I go to Assets, I go to New Assets, I go to Shape Files, and I basically search for my uh, files. So I've got, and there they are, points. Remember, I must select not just the HSP file, I must select all the files. And I simply this, sorry, it doesn't have a correct, doesn't want to have that one included. So it is that one, that one, that one, that one, and that one. Okay, I've selected all my files. I've given it a name. I'm not going to save it because I've already saved it. But yeah, you just now basically, if you go there, you basically just press upload. If I change this now, let's say to 1, it will just keeps on telling me. So let's just make it, okay. So now change the name. It will give me an upload option. I just simply upload it. Once I've uploaded the file, you just give it a couple of minutes and you just refresh, and then you go down the column, the list, until you find the file name. And there it sits, West Coast Points. Remember, I can either, if I just left click on the name itself, it will give me this little window. Now, please take note of the features. Please make note that you have the unique identifier and you have the coordinates. It's important. The unique identifier basically just lists all your features from 0 to 200 or 0 or 1 to 200. just go there and show that. You'll see there, it's the random point. It's listing it from 0 to 199, meaning to 200. So that's very important to understand, to make sure that you've got a unique identifier and you've got the two coordinates, the x coordinate and y coordinate. And please call it x coordinate and y coordinate. So that's very important. The rest, not too much. And then you import and it will close. So I've added that. Now I'm also going to then include the first piece of code. Obviously, I'm going to name it ROI locations. And again, that is discretionary up to you. And then I'm going to add that point shape file to my map. So that use that piece of code called map.layer. And then obviously the name of the variable. In this case, I'm going to make it orange and I'm going to give it a name. So if I go to my layers panel, you'll see there it sits. So if I just indicate it to you, there it sits. So it's displayed as little yellow points, which is obviously the 200 points that I've generated, random points that I've generated within my region of interest. You'll see there's my region of interest is blue, and all the points are located within the region of interest, and they are fairly evenly distributed. Obviously, there's some areas where there are large areas where there's not. So you may want to rethink your distribution of the points, rerun your random points, maybe give it a distance specification, etc., etc. But for now, let's leave it like that. And my map center is still the same. So that's the first two important points, actions that you have to do in terms of generating. So what we want to do now is we want to generate a time series or the data for my specific period for each of these locations. And I'm not going to do it for the DMSNP because that's annual. I'm interested in the years because this is the most recent and it's also monthly data. But you can do it for the DMSP annual as well. So I'm going to use it for years. So I want to calculate the average radian, which is the band, for each location from 2013 to 2023. And I'm going to use and then we have to decide whether we're going to use the mean statistic, the medium statistic, or the sum statistic. So let's progress down. You'll notice that the script is becoming significantly long now. Remember, there's our script for the time series for the region of interest as a whole. We have generated two charts. And there the two charts are, and you can, there they are, and you can see it is, and these are obviously for the region as a whole. So now what I want to do is I want to create a time series for each and every single location. So first I need to do is I need to instruct the editor or the engine to refer to the points. Use the points file as a reference. So I use the feature collection. So I'm creating these points as a feature. So I'm creating EE stands for Earth Engine dot feature collection, and then you simply just copy the link to the file. Where do I get this link? If I go up where I've imported you just click on that little sign and you see there's the ID. And you simply just copy that ID, meaning the link to the points folder or the points file. That's the ID there. You simply just copy it and you paste it into that specific line or that specific piece of code. So now you've created a feature collection with all your points, and I've named it ROI LOC, the same as this in front. You can give it a second different name. That's again up to you as discretionary. Then in this case, I'm just printing the size of it, meaning when I run this code, it will calculate how many points there are. And I do this just to make sure that I'm working. And you'll see there the outcome is it's 200. Remember, 200 is what we've created. So that's just a piece of code just to make sure that it's loaded correctly and it has identified each and every location. Um, which image or data set am I going to use? I'm going to use the VIRS data set, and I'm going to use it from 2012 to 2013 for my specific region of interest. And the band that I'm going to use is the average radius. Now, uh, if it's multiple bands, you have to include those. If there's multiple bands, you can include them as well. In our case, it's just one band. And obviously, that's the names that I've assigned to each of these variables that I've created. Again, these signs are discretionary. So I've created a feature collection, which is my points or my locations within my region of interest. And I've created the image collection, which is my data set or my VIRS based on the average radiation band. So that's the first two steps that you have to undertake post the creation of your random points and post the uploading of that random points file into your Earth Engine. Okay, so now the next step is just the standard code, which you then will you can just copy and paste. And there's a couple of items that you need to make sure of. First, if there's a scaling vector or scaling needs to be done to those numbers, then you will use that specific piece of code. In our case, we don't have any scaling, but I'm still leaving it in for just in case. So, for example, if there's in the data sets, it indicates that you have to scale it by a multiple of 1 or 2s or whatever the case might be. You'll simply just add it in. In our case, I'm taking the value as presented in the data set and I'm just returning the value itself, i.e. I multiply it by 1. So I'm not doing any scaling there, but that's just, if there's scaling, that's important. And then obviously I'm going to require the data from the start date to the end date, i.e. from the 1st of the 4th, 2012 to the 1st of the 9th, 2023. Then it's going to ask me a whole lot of information regarding the location itself or the images, meaning I'm going to reduce it into the regions, i.e. into the 200 areas. So I'm not taking the whole region of interest. I'm going to reduce it to the 200 points. And that's what that basically means. It means take my region of interest, reduce it to my 200 points. And in my case, I'm going to use the sum calculation or the sum statistic on the band. Scaling factor is 30. Again, you can play around with it. That's too much, not too much. And these pieces of code you leave exactly as is. You don't change it. Okay. Print, just to print this particular piece of code to see how it looks. And there it sits there. And you'll see it includes basically all of the information that, remember, there's the important unique identifier, and there's the important X and Y coordinates, and then obviously this value there corresponds to this one there. Now, if I go into my points, if I go to open attributes, you'll see there's the object ID, and in our case, if I go to it's the image ID. It's not, and there's the object ID corresponds to the object ID there, etc., etc. But what it does, it creates a new ID, which is called the image ID, which is the date. You'll see that that's the date. So it's creating a new variable or new ID within this, which is called the date. You'll see it's not visible in the spreadsheet, in the main file as yeah, so it's not there, but it's creating this. The next set of code is basically just to match. Now that you've created, remember now in this case you've created a new spreadsheet, and what you're doing here is you've actually matching, or you're creating the data within the image, and now what you want to do is you want to match it with the spreadsheet that you've just created. Most of the code is standard code, so you don't change it. Just make sure that in this case you change the band. Make sure the band details are correct. The rest are exactly the same. And now basically you are creating the time series. And this is where it's important to make sure that that name is specified, because now the time series have to be added to um, the each location. And remember, each location has a unique identifier, which is under this rand dot point. Remember, there's that value there. So that's very important. And then you match the year. So in this case, we're matching the data for each year with each location. So that's very important here. So please make sure that the RAND point and the image ID corresponds to the headings or the headings in your spreadsheet that you're generating. And then basically we're going to export this new spreadsheet in as a CSV file. So what are we going to export? We're going to export the time series results, which is this one here, which is the data connected or aligned to the location and the date. And I'm giving it a name, and I'm saving it to my folder as previously. I'm giving it a prefix. You don't have to do that. And it's being saved as a CSV. And you simply just click on run. Okay, so it's a long piece of code to generate the spreadsheet. But it's not a difficult code as long as you understand the three important parts in that is it's random points. Random points must have a unique identifier. Each random point must have an X and Y coordinate. And then for each random point, you'll create a time series based on the specified period that you've created in your image collection. And each of them will have a specific heading. And it's important to understand those headings and where they fit within the code. So if that heading, say, let's say image ID, is spelled differently or it's a different name, then make sure that all references to it in the code is changed as well, or the rand underscore point. Otherwise, it's not going to work. So that's very, very important. If you need the code, just give me an email. I'll happily forward the code to you. Okay, so once I've pressed run, you'll see for the export.table.drive, just like your previous exports, that task will now be located in the task column, and there it sits, the description, VS nightlife location, there it sits, and I simply just press run. Remember, it will give me a little window. Remember, no spaces. You click run, and you give it a bit of time, and at some point, the CSV file will be uploaded into your folder in your Google Drive. So if I click there, and there it sits. Sorry, not that one. Yeah. Yeah, and there it sits, CSV file. So I can simply go there and I download it. And once downloaded, it will be available in your on your hard drive, and you simply just open it. And I've opened the CSV and I converted that CSV file into an Excel file. And this is what I have here. This is what I'm looking for. So you can see there's the date from the 1st of the 4th, 2012, right through to the 8th month of 2023. So that's my time series. And there's you see, there's I'll just open it. There's unique identifier for each location within my region of interest from 0 to 199. And then next to that, it's the coordinates of each of those locations. So we've created now a spreadsheet with the time series data for nighttime light intensity for each of these random locations. So I can now take this and let's say I want to just create a graph of the first location. So you just basically highlight that and you just go insert as per normal, and you just press a line graph. So that is the night light intensity behavior in time series format for that specific location, which is location 0. Now we don't know exactly, we can now go within our QGIS. I can, let's just delete these ones. I can go and go properties, open attribute table, and let's see if I can highlight. There is location 0. It's that one there, highlighted. So that location is highlighted there. It's time series night light intensity footprint in time series format looks like that. And I can, so you can highlight now any one of those locations and you can generate a time series for its night light intensity footprint over that period of time. What we can also obviously do is to zoom into these specific areas just to make sure, and that takes a little bit of practice because you have to be very precise when you press on the inspector. So let's see if we can, if we're lucky. Let's see if we can zoom in. Let's make it a bit bigger and see if I can zoom into this particular location. Then I'm going to use the inspector function, and we're going to see if we get the same data. Okay, so but we have to, unfortunately, it's very difficult because you have to be very precise so that the inspector is exactly identify that, and you can't zoom in unfortunately anymore. So let's see if I was lucky to get it right. Let's bring it down. Now you see it doesn't align. It gives you a 0. See if we've missed it. But you can play around and try again and again until the data is there, and the data that's generated in there should then correspond to whatever the location is of the data of the location as per your spreadsheet, just to make sure that the data is correct. So there's the code again. Let's just go back. As I said, you first upload your points and then you create a feature collection with your points. Then you upload your images, your data set. And I said, in this case, I use the VS, but you can use your DMSP. You give it, you clip it to your region of interest, not for your locations, your region of interest. And you generate a time frame for it. And then basically, you just use the code to basically download the data from the images or from the data set, and then create a new spreadsheet, and then basically upload that data to your new spreadsheet based on its unique identifier, location identifier, and its date identifier, and you simply just export it. And that is how you generate time series for multiple locations within Google Earth engine. So I hope you enjoyed this particular tutorial, and stay tuned for more exciting tutorials to come. And thanks for joining me on this explanatory journey into remote sensing, and I'll see you soon.